In Rn, when you talk about planes, again, like with lines, you basically think about of some vector equation. That's all there is. That's all we think about of planes when you, because like I said many times already, we don't have any geometrical understanding of Rn. We never seen it in our life. As long as n bigger than 4, that's it, bigger than 3. So that's why we just model our experience with Rn with our experience with R3 and R2. Well, R3 in fact, because in R2 we don't have much of the planes too, it's only one plane there. So algebraically or in vector form, plane is always something like this. It's the equation. It looks similar to the line, but this time we operate with 2 parameters and 3 vectors. Geometrically, this is explained by this picture. If A is a position vector, so A, B, and C is Rn vectors, and you think of A vector as a position vector of some point. So here's your position vector, and here's your directional vectors A and B, B and C, sorry. And that's why we just this vector equation, we call it equation of the plane through the tip of the vector A parallel to the vectors B and C. If you vanish one of the parameters here, for instance, if you take mu specifically 0, then the remaining part of it, this one, will be a line. And that actually reflects the fact that the line which goes through the vector B like this, it will be sitting in your plane. In fact, I think I have a diagram of this line. That's the one. So this is the part of the plane which is traced by your x vector when you set mu equals 0. So you set mu equals 0, and you let your lambda run. Similarly, if you set your mu, for instance, 1/2, what will happen with this line? Which line we will trace on our plane? If I take not 0 here to vanish my C presence, but if I take 1/2 here, so the C will be present, but we just fixed 1/2 coefficient. The remaining bit, I mean this whole thing, with mu equal 1/2, for instance, it will be equation of some line. Do you see this line? It will be the line which is parallel to this line, but shifted by the half length of C along C direction. So it will be the line like this. Oops. It will be the line like this. Look at this. So if you keep changing your mu, if you keep taking different mirrors, for instance, if I take mu equal 1, what will happen with this line? It will get another shift, another push by half length of C in the C direction, right? So if I trace now the line, oh Jesus. If I trace now this line, you see, A plus, well, probably don't see. That will happen with that line. Similarly, you can fixate this presence, and you can let mu vary, in which case you will end up with lines which goes this way, parallel to C for fixed B's. For instance, if I fix lambda 0, I will have this line. And if I keep changing my lambdas, for instance, if I take 1/2, this line will get a shift along B by the half length of B. That's another one. So that's effectively, I hope, it explains why this is called the equation of the plane, because when you play with these lambdas and mu's, you will have this series of self-parallel lines in one direction, in direction of B, or in direction of C, and all of them together will compose your complete plane. And that's one of the ways of looking at the vector equation or parametric equation of a plane. Yes? Similarly to the way we did the line, I also give you the other version, or the other slightly different way you look at the equation of the plane when your setting is like this. When you have 3 given points, like this, and you wonder how to come up with the equation of the plane for these three points. I'm sure most of you will be able easily to reduce it down to this question, but still having the direct explicit formula for this setting is useful, like with the segments, we just did example. Remember the line segments? The same story goes about the plane. So if I have 3 points like this, so I have position vectors for each of them, for each of these points, if I have a position vector for each such point, so that's the explanation for that. Position vectors for A0, A1, and A2. The corresponding equation of a plane in this setting, it will look slightly different from this. It will look like this. I don't remember where I put it. Here. It will look like this. X equal, and that's the equation of that plane. Compare this with this equation. Right. Yeah. Of course, you can if you rename your points slightly differently, for instance, if you call this point A1, this is A0, and this is A2, you will have some rearrangement here, but effectively it will be the plane through the tips of 3 position vectors. I have a few sort of examples here. For instance, if I look at the line A0, A1, what should I do with my equation here? What should I do with this equation to come up with the line A0, A1? I have to vanish mu. If I vanish mu, which means I will vanish presence of this A2, the remaining bit, this mu will also be vanished, the remaining bit will look exactly like the equation of the line through 2 given points. And that will be the line A0, A1. I think I have a trace of that. Here it is. So in this equation of the plane, if I vanish mu, and I keep only lambda, that would be the line, it would be this side of this triangle, A0, A1. Of course, if in this parameterization you extra put lambda within these bounds, you will have with the parameterization, not of the whole line, but only this segment, A0, A1. Similarly, you can do the trick for the A1, A2. For the A1, A2, you have to vanish, oops. Actually, for the A1, how come? For the A1, A2, it's not exactly similar. I meant to say for the A0, A2. It's a similar thing, but you vanish lambda equals 0. For the A0, A2, if you vanish lambda, you will end up with this line. That's a tracing of it. A harder thing to see is that what happens if I want to come up with the equation of lambda or of the line A1, A2. And I already opened the answer for you. You have to set your parameters like this. It's not like direct vanishing. It's slightly more advanced than that. But actually, if you set your parameters like this, you will vanish something. What will you vanish? You will vanish this presence. And if you actually, in this equation, if you solve for one of them, if you say mu equal 1, take lambda, if you solve for one of them, and if you substitute this in here, you will this bit will look again like the equation of the line. And that's why you will have this line.